Today we're going to see how we do the state space form and also the transfer functions using this electrical system. So in this case we're going to have to define the first what the outputs are, and here, okay, let's say first we're going to say on the outputs we are going to define let's see this let's call it see this, you have the numbers here, but I'm just gonna do like L1, and this is gonna be R1. Let's call this L2, and this is gonna be C. And also it says voltage output, so the outputs in here B sub L2 is one of the outputs, and the other one is B sub C. I'm just gonna do both of them, okay? And the objective that we have, okay, let's just say objective, the transfer function and of course steady state space form of the equation. So if we do this using the bond graph method, how should we go about doing the bond graph first? You could draw it directly onto the circuit in here. This is the current I1 like this. This is the current I2 here. You could directly draw it just on the graph. So I will just do a one junction for I1, and I do a one junction for I2. So if you want, we could just write those steps in here. We're gonna call it the step number 1. Use a one junction for every current. Okay, very good. And then 2, you would say attach all elements that experience those currents. So that's going to be in this case you have the right here. So I would say that I attach this I element in here. For this would be L1. I attach this I element, which would be L2. I attach this C element, which would be this on the right hand side. And in here we have the voltage source with value B here. And now in between these two we have this R element between these two. This is I1 minus I sub 2. We connect the R element. This is our bond graph model. So we describe this in here just to be consistent, and then you would say use a zero junction to represent the current differences, and then you will say attach the elements that experience those current differences. Okay, that's what we have right now. So what we need to do now is to obtain the state space form and the transfer function using this example. So let's just go over here, and perhaps we will, it's important to have the bond graph model on site. So I am going to reduce the window like that and go to the CampG software here. Okay, so let's just keep it in here for now, and then we will go and run CampG, which in our case is over here. Alright, so what we need to do right now is to say, okay, look, this is a new model in here, and I'm going to put that on the left hand side and the CampG window on the right. So it doesn't matter how you start, but you should do this. Put the one junction over here like this, and then connect, and then you have the I element over here, and then connect. We're going to do it exactly as I have it on paper, okay? There's the 0 over here, and connect. Then there's this one right here, and connect. And then there is the R element over here, and connect. And then you have the 1 on the side, connect. And then we have a I element over here, and then finally we have a C element on the side. Yeah, okay. Now what we are going to do is we are going to obtain the state space form and the transfer functions that this problem is asking us to do. I think that my next step is to obtain it in the symbolic form, but given the fact that the problem gave us some numbers, we can use those to obtain the state space form, the transfer functions in the numerical form. But once you do that, you should be able to test the system by putting like a step input or impulse input to test it to see whether it works. So in here, I'm gonna go to the, first of all, I think it would be nice to save this in the form that it is, in such a way that we can refer to it. Okay, so I'm gonna put the the bond graph model as it is in here. Just gonna put it in the notes over here, the notes that we're building. So the bond graph model as entered into CampG is this. So now once we have this here, I go and say, okay, I need to go and do the interface to MATLAB, and you say, okay, yeah, go ahead and do that. Then these two programs do a handshake with each other, and at this point we need to define what the outputs are because the program doesn't know. So in here we have, let me make this fonts a little bigger for you so that we can very clearly see. So let's go over here, click OK, and so now we can see this. We're going to work with this file which is called camgsym, which means CAMG symbolic file. This file contains the state space form as well as the ability to obtain transfer functions. Because we don't know, rather the program doesn't know what outputs that we want, it is important to tell it. And in fact, if we go over here, we can actually tell the program which ones are the ones that we want. See right here, we are asked to find out the voltage on this inductor. I think that was in here. Remember, maybe to the right there. The voltage across the L2 and across the C. So that corresponds to E sub 7 and to this other one to E sub 8. So those are the two outputs. So you have to tell it what the outputs are. And so you go in here and you say, okay, find E sub 7. Yeah. And the computer shows us where E sub 7 is defined as an output. Let's activate these three lines. Let's call it this output number 1. And because by now you know that what we're doing right now is building the C and the D matrix, we have to put the 1 in here. And then we go back in here and we say, find me E sub 8, wherever it is. And there it is. And we are going to activate the three lines, define this as output number 2. Okay. And then this, of course, would be also row 2. And then row 2. And that's it. Once we have that done, we could just go over here and say run. And the computer is going to run. It's going to tell me, okay, these are my state variables. And this is my A matrix. Okay, so let me see if I can make it a little more visible. There you go, A matrix. And then you say B matrix. Then there's the C matrix. And there's the D. The characteristic polynomial. And remember, on this version of MATLAB, we need just a small modification on one statement here that the new version doesn't like, and that is this. We might have to run it again because this version doesn't like that statement. Okay, here you go. In fact, that's what happened right now. So what I would do is we're just gonna run it again. And there's the A and the B and the C and the D matrix, and there it is. Now they've got it all fixed up. So this is the first transfer function, the one on the top, and the second transfer function is the one on the bottom. This is pretty nice because now you see the coefficient of the numerator is made of these three physical parameters, and the ones on the denominator are also indicated here as well. for both of them. So this if we don't have numbers, these are the transfer functions, and this is the state space form. So you have everything right now. But if I say press to continue, the program is not going to go on because, hey, you know, I don't know what the numbers are. So what we're going to do to cure that is we are going to go to the beginning of the file here, and here's a place to put the numbers right here. See, this is I sub 2, I sub 7, R sub 5, and R sub 8. So if you remember from our graph in here, you have that I sub 2 is 2 henries. So let's just put that in here, okay? I may move this, make it a window so we can work it out. So I sub 2 is, how much is 2, right? From the left, right here, R sub 5 is 1, okay? And then I7, which is this one right here, is 3. No, I2 is, excuse me, I am confused. This is 3, and this I2 is 2, right? Yeah. And then C sub 8 is 0.5. 1 divided by 2, like that. Okay, there you go. Once you put the numbers, this is pretty easy. We are able to we should be able to run it again. What happens is here is the computer has not the see, we need to quit that, and then we have the editor in here again. Okay, so we're gonna run this again, but now with the numbers. Okay, so here we go. Now this is with the numbers right there. And there are A, B, C, D matrices. This is the characteristic polynomial. And these are the transfer functions, but now in numerical form. And once we have the numerical form, if you ChemG is meeting in it tells MATLAB to do some of the tests in here, which are typical for, you know, this step is step and impulse response. So that's what you see right now, the step and impulse response for both of the transfer functions. So that completes the whole process of getting the bond graph model done, getting the state space form both in symbolic and numerical form, and also doing the input and step, impulse and step response test.